Good afternoon. I am Dr. Snehashis Chakraborty, and I am going to talk about just the concept between probabilistic and deterministic approach for process time calculation. The thing is that when you have to process any food, always we keep on asking that how much time it has to be treated at what temperature. So obviously the question or calculation it will come that D value, decimal reduction time. What is that? That the if our microbial load or microbial population within the system is like X, how much time it will require at particular temperature to reduce the microbial load by point X. That means if it is 1000 initially, how much time it will take to reach 100. So 10 times reduction is your time. So the always we calculate that log of n by n0, that is initial count, and final count versus t, that is semi logarithmic curve. That is, we are forcefully trying to give the or try to fit it in semi logarithmic curve, so that the time can be calculated as the slope, that is your decimal reduction time. So here the silent mode is that the order of the inactivation we are taking 1, that is a first order inactivation. How much that is realistic enough, it has to be checked first. That in case of chemical reaction, when we say this is reaction order, that means here all the molecules are similar in nature and they will behave towards the reaction equally. That is totally understandable. But in case of microbial inactivation, we are following the reaction order concept and we are assuming n is equal to 1. What is the implicit assumption of this first order kinetics is that each and every microorganism, if it has been kept under stress, it will behave towards the stress equally. That is not at all true. You can imagine within this room itself, if I immediately say that after this talk I am going to ask you each and everyone one question. So it will be one type of stress towards you, but you, all of you or every one of you will not react towards the stress equally. So if this is the full of microorganism within the food system, if I apply the stress like temperature increasing or pressure increasing, all of the microorganism will not react towards the stress equally. So how can we take the n is equal to 1 in case of that system? That means we have to assume that within this food system there is a group of microorganisms. Let us take if the microorganism is of lag phase, is of log phase, is of stationary phase, those will have the different resistances and they will act towards the stress equally. So within the system itself there should not be a deterministic approach, that means that each and individual microorganism will react towards the stress equally. Instead we have to take that we have group of microorganisms having the equal resistivity, that is the probabilistic concept within the system. And this probabilistic concept has already been featured through Weibull distribution model, that in that what we are going to take the shape of the microbial inactivation curve is called also in reflected interest in case of order of the inactivation. Normally the nowadays the calculation of all these microbial inactivation kinetics is doing through nth order model, not assuming n is equal to 1, because if n is equal to 1, assumption will lead to at least 2 to 3 under or overestimation of the process time. It will cost the industry a lot. So that's why what is the take home message from this talk, that when within the food system there is microbial inactivation occurs, let's don't take or assume the order of the inactivation 1, let us go for or check the order of the inactivation, then calculate the decimal reduction time and then go for the calculation of the process time. It will help the industry to reduce or to adjust the cost towards the processing. That is all. Thank you.